Introduction. Students, in the previous part we have learnt the isomerism and fundamental concepts used in the organic reaction mechanism, and today we learn the methods of purification of organic compounds. Some of the methods are sublimation, chromatography, distillation, etc.
Teacher, what is sublimation?
Sublimation is the process in which solid directly converts to vapor state without passing through liquid state upon heating. Now, can anybody tell me what is chromatography?
Teacher, chromatography is a technique used to separate and analyze a mixture of chemicals.
Very good, Aryan. Now we'll study the processes of purifications in detail. In this lesson, you will learn purification of organic compounds, qualitative and quantitative analysis of organic compounds. Objectives. At the end of this lesson, you will be able to describe methods of purification of organic compounds, explain qualitative analysis of organic compounds, describe quantitative analysis. Methods of purification of organic compounds. The various methods for the purification of organic compounds are sublimation, crystallization, distillation, differential extraction, and chromatography. Sublimation. Some solids change directly from the solid state to vapor state on heating. This process is termed as sublimation. It is used to separate sublimable organic compounds from non-sublimable compounds. The impure organic compound is heated in a dish covered with perforated asbestos sheet over which an inverted funnel is placed. The stem of the funnel is filled with cotton, and on heating, the part of the solid which sublimes passes through the holes in the asbestos sheet and condense on the cooler walls of the funnel. The non-sublime impurity. Crystallization. It is the most common way of purification of organic solids. It is based on the difference in the solubility of the organic compound and the solvent in which the organic compound is mixed. The impure substance is in powder form and then heated with the solvent in a flask. The amount of solvent should be just sufficient to dissolve the substance on heating. The hot saturated solution is then filtered with the hot water funnel. The hot water circulated in the outer funnel keeps the solution hot, and crystals cannot be formed in the funnel itself. The hot filtrate is cooled in the beaker and large crystals are obtained, and then the crystals are separated from the filtrate by means of filtration. Distillation. Distillation is a method for purifying liquids and separating mixtures of liquids into their individual components. On heating the liquid mixture in a flask, the components in the liquid which have low boiling point start vaporizing. The vapors are condensed in the condenser and the resulting liquid is collected in a receiver. The components of liquid which have higher boiling point vaporize later and the liquid can be collected separately. Fractional distillation. When the boiling points of the two liquids are very close, then simple distillation does not work. In that case, a fractionating column is used, which is long tube provides obstructions to the passage of the vapors upwards and to the passage of liquid downwards. The mixture of liquids A and B with 370 Kelvin and 380 Kelvin respectively boiling points is present in the flask. On heating the flask, the vapors obtained are more of A and less of B. As the vapors rise up in the fractionating column, the partially condensed liquid flows down. The vapors of B condense faster as compared to A, and the vapors moving up richer in A. The condensed liquid flowing down strikes the vapor and it consumes molecules of B. This process is repeated throughout the fractionating column, due to which the vapors escaping through the top of the column are almost of A and the liquid left in the flask almost of B. Distillation under reduced pressure. This process is used if the liquid has a tendency to decompose near its boiling point. The main neck of the flask is fitted with long capillary tube and the side neck fitted with thermometer. This side tube is connected to a condenser which is connected to the receiver at the other end. The receiver is connected to a pump which reduces the pressure. Under reduced pressure, the liquid will boil at a low temperature and the temperature of decomposition will not be reached. For example, glycerol boils with decomposition at 563 Kelvin, but if the pressure is reduced to 12 millimeters, it boils at 453 Kelvin without decomposition. Steam distillation. This method is used to separate the substances which are steam volatile and insoluble in water. This method based on the fact that a liquid boils at a temperature when its vapor pressure becomes equal to the atmospheric pressure and the vapor pressure of a mixture of two immiscible liquids is equal to the sum of the vapor pressures of the individual liquids. Steam is continuously passed through the compound which is required to be distilled. Steam heats the liquid and also condenses to water. After some time, the mixture of water and liquid starts boiling because the vapor pressure of the mixture becomes equal to the atmospheric pressure. The temperature at the instant is lower than the boiling point of the substance or that of water. The mixture of liquid and water is condensed and collected in a receiver which can be easily separated. Differential extraction. When organic compound is present in aqueous solution, then the organic compound is extracted by using a solvent in which organic compound is more soluble than water and the solvent is not miscible with water. If the organic compound is less soluble in a given solvent, then a very large quantity of solvent is required to extract a very small quantity of the compound. This technique is known as continuous extraction. Chromatography. Chromatography is a technique used to separate the components of a mixture to identify organic substances and examine their purity. Classification of chromatography. Adsorption chromatography, partition chromatography. Adsorption chromatography. Adsorption chromatography is based on differential absorption, that is, different compounds are absorbed on adsorbent such as solid, SiO2 gel or Al2O3 to different extent. Based on differential adsorption, there are two types: column chromatography and thin layer chromatography. Column chromatography. It is the process in which the mixture of various components, when passed through a column containing an adsorbent such as starch or charcoal, the different substances are absorbed to different degrees and thus they can be separated with the help of suitable solvent called eluent. Thin layer chromatography. It involves the spreading of the thin layer of adsorbent on a suitable support such as glass plate, etc. The glass plate is known as thin layer chromatography plate or chroma plate. The mixture to be separated is applied as a small spot from one end of the TLC plate. The glass plate is then placed in a closed jar which contains the solvent. As the solvent moves up in the jar, the components of the mixture move up along the plate to different distances depending on their degree of adsorption, and separation takes place. The relative adsorption of each component of the mixture is expressed by retention factor, that is RF value, which can be given as RF is equal to distance moved by the substance from the baseline by distance moved by the solvent from the baseline. Partition chromatography. Partition chromatography is a paper chromatography in which a special quality paper known as chromatography paper is used. Chromatography paper contains water trapped in it, which acts as the stationary phase. The chromatography paper is placed at the base with the mixture of solvents. The solvent acts as mobile phase. The solvent rises up in the paper and flows over the spot. The different components are separated according to their differing partition in the two phases. The developed paper strip is known as chromatogram. The colorless compounds may be observed either under UV light or by the use of an appropriate spray reagent. Qualitative analysis of organic compounds. Detection of carbon and hydrogen. Carbon and hydrogen are detected by heating the organic compound strongly with copper-2 oxide. The produced gases are passed through anhydrous copper sulfate and then passed into lime water in a test tube. If carbon is present, then it forms carbon dioxide, which turns the lime water milky. The reactions are as follows. Carbon in organic compound reacts with copper-2 oxide and produces copper and carbon dioxide. The produced carbon dioxide reacts with calcium hydroxide, which turns it milky, indicating the presence of carbon in organic compound. If hydrogen is present in the organic compound, then it forms water vapor, which passed over copper anhydrous sulfate turns it blue by forming CuSO4 5H2O. The reactions are as follows. Hydrogen in organic compound reacts with copper-2 oxide and produces copper and water. The produced water reacts with anhydrous copper sulfate, which turns blue by forming CuSO4 5H2O. Detection of other elements. Other elements such as nitrogen, sulfur, halogens and phosphorus in the organic compound can be detected by Lasigene's test. The elements in the organic compound fuse with the sodium metal. The reactions are as follows. When sodium reacts with various elements found in the organic compounds, then it forms sodium fusion extract. Test for nitrogen. On addition of ferrous sulfate to sodium extract, that is sodium cyanide, it produces sodium ferrocyanide. The ferric ions generated during the process react with ferrocyanide to form blue precipitate of ferric ferrocyanide. Test for sulfur. If sulfur is present in the organic compound, then it can be identified by the reaction of sodium fusion, that is sodium sulfide Na2S with sodium nitroprusside. Then, violet color indicates the presence of sulfur. Test for halogens. The presence of halogens is tested by acidifying a portion of sodium extract, that is NaX, with dilute nitric acid and adding silver nitrate. If a white precipitate is formed which is soluble in ammonium hydroxide, it indicates the presence of chlorine. If a yellow precipitate is formed which is sparingly soluble in ammonium hydroxide, it indicates the presence of bromine. If the formed yellow precipitate is insoluble in ammonium hydroxide, then it shows the presence of iodine. If nitrogen or sulfur has been detected, The solution must be boiled for a couple of minutes to expel HCN and H2S which interfere with the test. Test for phosphorus. The presence of phosphorus can be detected by fusing the organic compound with sodium peroxide. The formed solution is treated with concentrated HNO3 and an excess solution of ammonium molybdate is added. A yellow precipitate indicates the presence of phosphorus. Quantitative analysis. Carbon and hydrogen. A sample of organic compound is heated to 700 degrees Celsius in a steam of pure dry oxygen and in the presence of copper-2 oxide. The hydrogen is oxidized to water and carbon to carbon dioxide. The amount of water produced is determined by passing it through anhydrous calcium chloride, and carbon dioxide is determined by passing it through solution of potassium hydroxide. The mass of hydrogen present in sample of organic compound will be 1/9, the increase in mass of the calcium chloride, and the mass of carbon will be 3/11, the increase in mass of the potassium hydroxide. Nitrogen. There are two ways for estimation of nitrogen: Dumas method and Kjeldahl's method. Dumas method. A known mass of organic compound is heated with copper oxide in the atmosphere of carbon dioxide. Under these conditions, carbon and hydrogen are oxidized to carbon dioxide and water respectively, and nitrogen is set free. If any oxide of nitrogen is formed, it is reduced back to nitrogen by hot reduced copper. The gases produced are passed from potassium hydroxide solution through furnace. Potassium hydroxide absorbs carbon dioxide and nitrogen is collected in the upper portion of the tube. Percentage of nitrogen in organic compound whose mass is m, Gm is 28 into V into 100 divided by 22,400 into m, where V is the volume of nitrogen at STP. Kjeldahl's method. In Kjeldahl's method, nitrogen is estimated by ammonia gas. The organic compound is heated with sulfuric acid. Nitrogen in the organic compound is converted into ammonium sulfate. The ammonium sulfate is then heated with excess NaOH and it liberates ammonia. The produced ammonia is absorbed in standard solution of sulfuric acid. The produced ammonia can be estimated by the amount of sulfuric acid used in the reaction. It can be done by estimating the amount of sulfuric acid left after the absorption of ammonia by titrating it with standard alkali solution. The difference between the initial amount of sulfuric acid taken and the amount that left after the reaction provides the amount of acid reacted with ammonia. The percentage of nitrogen is 1.4 into m into 2 times of the difference between V and V1 by 2 divided by mass of organic compound, where V is equal to volume of H2SO4 taken in milliliters, V1 is equal to volume of NaOH in milliliters, m is equal to molarity of H2SO4. Halogens. Carius method. A known mass of organic substance is heated with fuming nitric acid and then silver nitrate is added in the tube called Carius method. The formed silver halide is separated, washed, dried and weighed. Percentage of halogen. Atomic mass of X into M1 into 100 divided by molecular mass of AgX into M, where M1 is the mass of AgX formed and M is the mass of organic compound. Sulfur. A known mass of the organic substance is heated with fuming nitric acid. The sulfur is converted into sulfuric acid. The formed sulfuric acid is precipitated as barium sulfate by adding barium chloride. The precipitate is filtered, washed, dried and weighed. Percentage of sulfur: 32 into M1 into 100 divided by 233 into M, where M1 is the mass of barium sulfate formed and M is the mass of organic compound. Phosphorus: the organic compound containing phosphorus is heated with fuming nitric acid and phosphorus is oxidized to phosphoric acid. Phosphorus is precipitated as ammonium phosphomolybdate by addition of ammonia and ammonium molybdate. Percentage of phosphorus: 31 into M1 into 100 divided by 1877 into M, where M1 is the mass of ammonium phosphomolybdate and M is the mass of organic compound. Oxygen: the percentage of oxygen in an organic compound can be determined by the method of difference. All the elements in the organic compound except oxygen are estimated and the total of their percentages subtracted from 100 to get the percentage of oxygen. The organic compound is heated in the stream of nitrogen gas. The formed mixture of gases is passed through red-hot coke and oxygen gas is converted into carbon monoxide. Now the carbon monoxide is converted into carbon dioxide by mixing iodine pentoxide into the mixture. According to chemical reactions, the percentage of oxygen can be found as 16 into mass of carbon dioxide divided by 44 into mass of organic compound into 100. Did you know? Carbon occurs in all living organisms. Carbon is a nonmetal and that it can bond with itself and with many other chemical elements, forming nearly 10 million compounds. Summary: let us summarize what we have learned. Sublimation, crystallization, distillation, differential extraction, and chromatography are the methods for the purification of organic compounds. Carbon and hydrogen can be detected by heating the organic compound strongly with copper-2 oxide. Nitrogen, sulfur, and halogens can be detected by sodium fusion extract. The mass of hydrogen present in sample of organic compound will be 1/9 the increase in the mass of calcium chloride, and the mass of carbon will be 3/11 the increase in mass of the potassium hydroxide. Percentage of nitrogen in organic compound whose mass is mgm is 28 into V into 100 divided by 22,400 into m, where V is the volume of nitrogen at STP. Percentage of halogen in organic compound is atomic mass of X into M1 into 100 divided by molecular mass of AgX into M, where M1 is the mass of AgX formed and M is the mass of organic compound. Percentage of sulfur in organic compound is 32 into M1 into 100 divided by 233 into M, where M1 is the mass of barium sulfate formed and M is the mass of organic compound. Percentage of phosphorus in organic compound is 31 into M1 into 100 divided by 1877 into M, where M1 is the mass of ammonium phosphomolybdate and M is the mass of organic compound. Percentage of oxygen in organic compound is 16 into mass of carbon dioxide divided by 44 into mass of organic compound into 100.